world are exponents. Where did it come from? Well, first of all, we use multiplication to express repeated addition. So, for example, we can write 2 plus 2 plus 2 plus 2 as 4 groups of 2. So we write it as 4 times 2. So how can I write repeated multiplication, which, for example, would look like 2 times 2 times 2 times 2? Well, that's when we use exponents. So an exponent tells how many times a number is being multiplied by itself. And the base tells you which number you are multiplying. So, for example, this expression 2 times 2 times 2 times 2 is written as 2 to the 4th power. So let's identify the pieces. That 2 is our base, and that 4 is our exponent. Because the 2 tells me how many times the number, the exponent tells us how many times the number is being multiplied by itself. So this exponent is telling me it's being multiplied 4 times. 1, 2, 3, 4. The base tells you which number to multiply. So the number I'm being multiplied here is 2, so that's why the base is 2. And as I read it earlier, it's read as 2 to the 4th power. So I have 3 forms that I can see when I'm working with exponents. I have my expanded form, which is the stretched out form of the repeated multiplication. The exponential form is the expression to represent the repeated multiplication. So it looks the shorter way to write it. And the standard form is just the solution. So let's go ahead and fill out some of this base and exponents. So we're going to identify the base and exponent in each power. So the larger number is going to be my base, and my exponent is going to be the smaller number. So for the first one, my base is 16, my exponent is 5. Second one, base is 10, exponent is 3. And the last one, base is 24, exponent is 6. Remember, the base is the number we're multiplying. The exponent tells me how many times to multiply it. So this would be 16 times 16 times 16 times 16 times 16. I said 16 5 times. So let's go ahead and fill out a table. We have our exponential form, the base, exponent, expanded form, and standard notation. Remember, that's our solution. So exponential form is 2 to the 3rd power. So my base is 2. The smaller number is my exponent, and that's 3. And as I can see here, I have 2. I'm multiplying it out 3 times, and I get 8, because 2 times 2 times 2 is 8. Now let's look at the second one. 3 to the 2nd power. We have 3, which is our base, to the 2nd power. So that means I'm multiplying that 3 2 times. So 3 times 3, which makes 9. 5 to the 4th power. It's already in expanded form over here. We can see 1, 2, 3, 4 5s that are being multiplied together. So 5 is my base. 4 is my exponent because I'm multiplying it out 4 times. And if I do 5 times 5 times 5 times 5, I get 625. Next one, 6 to the 2nd power. I already have the base and the exponent. So I'm going to write the 6 2 times. And I multiply 6 times 6, which makes 36. All right, last two. They're telling me the base is 8. See, I'm multiplying the 8. How many times did I multiply it? I multiplied it 3 times. If I do 8 times 8 times 8, I get 512. Now let's write it in exponential form. The base is 8, so that's the large number, and the small number will be the exponent, 3, 8 to the 3rd power. Last one. We have 4 times 4 times 4 times 4 times 4. Well, I'm multiplying this 4 out, so that's going to be my base. How many times am I multiplying? 1, 2, 3, 4, 5. So my exponent is 5, so it's written as 4 to the 5th power. If I multiply those out, I get 1024. Another way I can be asked a question is to find the value of the power. The power is the entire thing that I've written here. It's just a way to write repeated multiplication. So this one, 10 to the 3rd power, is 10 times 10 times 10. If I multiply that out, I get 1000. Now let's look at a tricky one. Find the value of the power, 2 to the 0 power. So let's go ahead and look at some 2 to the other powers. So if I have 2 to the 6th power, it's 64, 2 to the 5th power is 32, 2 to the 4th power is 16, 2 to the 3rd power is 8, 2 to the 2nd power is 4, 2 to the 1st power equals 2, and 2 to the 0 power equals, we don't know. A lot of people think it's going to be 0, but let's reverse this. Instead of multiplying, we're going to divide. So if I take 64 and I divide it by the base, which is 2, I get 32, which is this answer right here, because I have 1 less 2 that I multiplied. That makes sense, right? So if I divide 32 by 2, I should get 16, which I do. So I'm multiplying 1 less 2. So I'm going to keep dividing the base and make sure it matches. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. So what's 2 divided by 2? It's 1. So any number raised to the 0 power has a value of 1, no matter what. Because I can do this for any other base. So if I had like 3 to whatever, I could divide out the 3's and I should still get 1. A couple more things to work with exponents is we have some special ones that we use different wording for. So a power with an exponent of 2 is read as squared. So for example, 13 to the second power right here, I can also read it as 13 squared. Now, a power with an exponent of 3 is read as cubed. So instead of reading this as 5 to the third power, I can also read it as 5 cubed. And that is exponents.